All right, welcome back, class. Today we're going to finish up 6 to 7, dealing with the inverse relations and functions. So, the inverse of a function f is denoted by f to the negative 1. You read f to the negative 1 as the inverse of f or as f inverse. The, the notation f of x is used for functions, but the relation f to the negative 1 may not even be a function. Now, remember, we talked about that yesterday, how even if you're starting with a function, sometimes what you're getting in its place is not a function in return. All right, so we do have to be careful with that some of these things are not going to be functions. So, let's take a look. So yesterday we focused a lot on graphing because I wanted you to visually realize that when you take the inverse, you are reflecting the graph over the line y equals x. Now today that's not as important to me. Today we're going to be focusing more on just the strict mathematics of it. So finding the inverse, dealing with domain and range, all of that fun stuff. All right, now speaking of domain and range, that's where we're going to begin all of our problems today. So looking at this one, we want domain and range. Well, for the domain, what we're looking for is what values can we use for x? Well, remember when we're square rooting, we have to say that the inside of the square root must be positive. That is restricting our domain. So what ends up happening is you can only use x values that are greater than or equal to 2. So that's going to represent our domain in this case. X values that are greater than or equal to 2 because you can't take the square root of a negative number. Range. Well, the range, if you think about it, even though we don't really know what this looks like, all right? However, if we think about it, if the square root of something, if you can only have positive values, you're only going to be getting the positive values out. Oh, I'm sorry, not x. That is going to be y is greater than or equal to 0. Because remember, when the root is already written out, we only get that principal value. We only get the positive value. So in this case, by taking the square root, we know we're only going to be getting 0 and positive numbers. All right, so what is f to the negative 1? The inverse of f. So let's take a look at this. So it says switch x and y. So by x and y, I mean really there's no y written there. But remember, when you use f of x, you can always think of it as y. So I'm going to switch x and y. And now it says solve. Okay, we need to resolve for y. Okay, well, we have a giant square root there. So to get rid of that giant square root, let's just square both sides. Remember, squaring undoes a square root. And then I'm going to add 2 to both sides. And there is my inverse. All right, so what are the domain and range of f to the negative 1? So what I want us to think about is domain and range. Well, it says we're going to switch it from the domain and range of the original function. So what that means, this range right here is now my domain. The original domain is now my range. So all you really do is flip-flop those values. So now that range of y being greater than or equal to 0 becomes a domain of x being greater than or equal to 0. The domain of x being greater than or equal to 2 becomes a range of y being greater than or equal to 2. Okay, so all you need to remember is that you flip-flop those. Now you do have to make sure you're still using the right variable. Domain, you always use X. Range, you always use Y. So you have to make sure you use the right variable. That doesn't stay with it. But the number is what you move. And is f to the negative 1 a function? Well, if you think about it, x squared plus 2, you know what that is. That's a parabola. So yes, f to the negative 1 is a function. All right, let's take a look at our next one. So we're considering that function, and we want to know what are the domain and range of f of x. All right, well, something that you should know, and this is something you probably wouldn't even realize, but I want you to see just a sketch of what a basic cubic looks like. So remember, that is what we're talking about. So we're talking about that kind of cubic. So domain and range, both going to be all real numbers. All right, now what is f to the negative 1 of x? What is the inverse? Well, remember, we're thinking of this as y equals 5x cubed plus 1. So I'm going to switch those numbers, or those variables, I mean. I'm going to switch x for y. And now I'm going to solve. So I need to get y by itself. Well, I'm going to subtract 1 from both sides. I'm going to divide by 5. And now to undo a cube. So to undo a cube, we are going to use a cube root. And there is our inverse function. All right, so we have our inverse function. Now, domain and range of f to the negative 1. So in this case, it's easy because both of them were all real numbers. And so now both of them are actually all real numbers again, because when you flip-flop them, they end up being the same thing. And is f to the negative 1 a function? Okay, well, here's a question that you may not know the answer to, because you probably have never seen a cube root function before. So I want you to imagine taking that graph and reflecting it over the line of y equals x. You're going to get something that looks like that. Now, if you forget, you can always use a graphing calculator to graph it. But if think about if this passes a vertical line test, the answer is yes. Yes, it does. So we are truly looking at an inverse function. All right, so speaking of inverse functions, here's a little fun fact about why both can be functions in some cases, but not in others. Why sometimes do we get something that's not a function? Well, you know that for any function f, each x value in the domain corresponds to exactly one value or one y value in the range. For a one-to-one function, it's also true that each y value in the range corresponds to one value in the x in the domain. So basically what it's saying is one-to-one means it passes something called a horizontal line test. So what I mean by that is that cubic that we were just talking about, You can draw horizontal lines anywhere and it only touches it at one point. So it passes the horizontal line test. So what that means is when you flip it, when you find its inverse, the inverse will pass the vertical line test and it will still be a function. Now think about a quadratic. When you try to draw a horizontal line there, it fails. So what that means is when you take the inverse of it, and now it's flipped, well, it's going to fail the vertical line test and not be a function. So in order for both to be a function, it needs to pass the vertical line test and the horizontal line test. That's how you can tell if a function and its inverse will both be functions. So, just a little fun fact for you. Now, another key thing here. When finding the inverse of a real world or of real world problems, we cannot just switch the variables. We simply solve for the independent variable or the input. So for example, for the area of a circle, we know the area of a circle is a equals pi r squared. So if we want it inversely expressed, we want it expressed for the radius, we don't switch the variables and resolve. What we do is you just undo everything to the one variable, and that's how we express it. All right, so you would just end up solving it for r. So the formula d equals 4.9 t squared represents the distance d in meters an object falls in t seconds due to Earth's gravity. Find the inverse of this function. How long in seconds does it take for the cliff diver, shown below, to hit the water? All right, so here's the function we're starting with. And it wants us to find the inverse function. So that means it wants us to solve it for t. So I'm going to divide by 4.9, and then I'm going to square root it. So the square root of d over 4.9 equals t. So that's what it means in a real world context to find the inverse. It just means solve for the other variable. All right, now going back, it wants to know how long will it take the cliff diver to hit the water. Well, that means I want to plug in that 24 meters. That's my distance, and I'm solving for time. So let's see what that is. Well, 24 divided by 4.9, that gives you kind of a nasty number, which we kind of expected. 4.8978 blah, blah, blah. And now we're going to take the square root of that. So, and this would be a perfect opportunity to be checking this with your calculator along with me. You're going to get 2.2 seconds. That's going to be how long it's going to take that cliff diver to hit the water. All right, last page. So the next thing that I want you to know is the composition of inverse functions. So what ends up happening is when you take the composition of inverse functions, you end up getting x back. Okay? So what do I mean by this? Well, when I compose these two functions, when I compose it both ways, if the result is x in both situations, that means that they are truly inverse functions of each other. So I'm going to take a look at what this means. So in this one, we're putting the inverse into the original function. So that's going to look like this. So I'm putting 1/2 x minus 4, I'm putting it into the 2x plus 8. So 2 And then in the place of x, I'm putting the inverse. All right, I put the inverse into the original function. Well, now to clean that up, I'm going to distribute that 2. So I get x minus 8 plus 8. Huh, look at that. I just got x, which again, my little key concept there was telling me that's what I should expect because this is a function and an inverse that we already knew about from yesterday's notes. Now let's try it the other way. So this time, let's put the original function into the inverse function. All right, so I put the original function in for x in the inverse function. Now distribute the 1/2, so you get x plus 4, then minus 4, and look, it happened again. In both situations, you just get x back. It's because everything else is undoing itself, because that is what inverses do. They undo each other. So the composition, you would always just get x back. All right, one last little concept. So something else I need you to know is if you're trying to find an x value that is not in the domains of the functions, the composition may not be able to be calculated. All right, because that domain has to work in both functions. So if in one of them it doesn't work, can't really find the composition. So here, f, oh, that's a -1. So here, I'm plugging in 1 into the inverse function and then plugging it into the regular outer function. So plugging in 1 to the inverse, so 1 plus 1 equals 2. So now I'm going to take f and I'm going to put that 2 in for f to the -1 of x. Well, 1 over 1. So that worked out. I was actually able to calculate that whole thing because that 1 was was a part of the domain of the inverse function. Well, let's think about the reverse of that. So in this direction is telling me, oh, I'm sorry, I'm writing that poorly. Telling me to calculate f of 1 first and then put that into the inverse function. Well, if I'm calculating f of 1, we have a problem here. I can't divide by 0. So what this means is you cannot finish that composition. All right? If in one of them the number doesn't work, you just have to stop with a calculation and say that you can't do it. So this one, you can't really solve. All right? There is no solution to it. So again, just a little tidbit that sometimes these things will not work out if you're putting in numbers not in the domain or range of the proper function. All right, so I apologize, these notes are getting a little bit long here today. So let's end there. I want to thank you for joining me. Please make sure you have all of this written down, and then I'll see you in class for your practice work.